That
During our computer-aided engineering class at Auburn University, we were tasked with combining our knowledge in SolidWorks to create a catapult worthy of launching a ping pong ball to an unknown distance. To begin our design process, our professor provided us a general concept for a ping pong catapult. The concept included necessary parts we had to include in our design, such as a rotating collar, throwing arm stop, leg, lead screw assembly, and overall frame. On top of the main design of our catapult, we were provided specific materials that we could use both virtually or physically if we chose to build our design. For our frame design, each group could have chosen to use either carbon fiber or fiberglass arrow shafts. Additionally, our project had to be confined to either a 6x6x6 or a 10x10x10 inch build envelope throughout our SolidWorks design and our physical build.
To begin breaking down the overall project, our group had to dissect the catapult. This included identifying each necessary attribute to the catapult mentioned in the project description. As engineers, we are familiar with the need to create multiple design ideas and narrow them down to an appropriate option. We began by recalling ideas from previous classes, such as high school engineering classes. Having varying educations allowed us to have over 20 different frame ideas during our first meeting as a group. During our meeting, we began by drawing every idea on a whiteboard and narrowing down repetitive options. This process also involved brainstorming specific parts located on the frame. One of these parts was the ball holder, as shown in this image.
Our group decided to go with a mostly square frame design, including 4 legs and a diagonal plate to house the lead screw assembly. While we decided not to build our catapult physically, if we were to, we concluded that the fiberglass arrow shafts would be the most realistic option in terms of price and durability. Separating parts of the frame became an easy way for our group to split the overall assembly. While the main design only included 8 parts, our design included close to 20 individual parts. Each part was designed first on paper, then in a rough sketch on a SolidWorks, and one of the biggest obstacles we faced during this process was setting correct dimensions on the parts for future assembly.
For part assembly, we tried to combine parts for the main items first. For example, we started by connecting all parts of the frame to build an ongoing assembly. The image shown is the foot set assembly, which is attached to the legs as the base for the entire frame. We have approximately 5 sub-assemblies included in our final design. Once all sub-assemblies were complete, the assembly was finalized in SolidWorks and ready for future production. After all the parts and sub-assemblies were modeled, each individual worked on drafting them. With the drawings completed, we conducted an analysis of the mass properties to deduce how much of each material was needed, as well as to figure out the amount of 3D filament needed to print our necessary parts. With the draft drawings, we were able to convey the dimensions to each of the team members, and from there produce a list of materials and the quantities in which they are needed. While our group did not physically build our model, we did stay under the budget stated in the project description and would be able to order and build our catapult.
A key part in our project was including a global parts list. Our assembly included materials such as the fiberglass arrow shafts, 3D printed filament, thin aluminum, alloy steel, and simple red solo cups. In total, our materials totaled $36.37. Throughout our work on this catapult project, we utilized several methods of communication in order to allow group members to be up to date on meetings and expectations. As a group, we used the app GroupMe to discuss meeting times, and it was our main source of communication. Google Sheets was used to keep all the documents in our global parts list. Additionally, when in-person meetings were not available, our team met on Zoom to keep the project timeline. Establishing boundaries on the project allowed us to assemble our catapult without worry of part failure. These boundaries included similar units as well as similar file names.
In summary, our catapult Our catapult involved several sub-assemblies to combine into a final sub-assembly that embodied our original draft on a whiteboard and brown copal. Throughout this process, we have all become more familiar with SolidWorks and its use for producing virtual and physical prototypes.